Okay, so this voltage vector minus this resistance vector, and here if you replace this value, it will, that inductance it will come. So that part if you replace it, and then if you, because it having two part, this R having two part, R vector having two part, and after that if you, because here also another thing it will come with terms of L, so that should be inverse. Then if you integrate it, you will get the current. So that only here we have done, you see. So this is basically nothing but L inverse, whatever the matrix L, that inverse, and this is basically integrated, because di dt term will be there, so that if you integrate it, I term it will come, and this term it is R1 matrix. Already I have splitted the R matrix to R1 and R2, so that means this this is your R1 and this is your R2. In that, with this omega R term it will be multiplied. So you see here, this is a product with I, and this is coming from, this is your omega. How omega is coming, I will tell you. Then after that, this is multiplied by R2, and both the things is subtracted. Then this is the loop completed, and you are getting the current. So that current I am taking here, and again it is converting to two phase to three phase. So here you see I have used that transpose of that. So that's why this inverted comma is called transpose. So here it is current. Now the torque equation, if you see the my vector control video, so there this voltage equation, I mean, torque equation is made in terms of dq axis. So here it is alpha beta axis, nothing but in place of d you can put alpha, and in place of q you can put beta. So after that, if you substitute the value of flux, and you convert the torque equation in terms of inductance and current, so it will come like this. So this is your is alpha, this is your is beta, ir alpha, ir beta. So that equation I have made, and this is the gain. It is that 3 by 2 into Lm by Lr. So Lr will be cancelled into P by 2. So that is that formula. And then this is the transfer function of the load. So it's a first order differential equation. You can see what is that induction machine torque on a load equation. It's a first order differential equation. It has been converted to Laplace domain, and this is your load torque basically. So that means your electrical torque is equal to J d omega